Good afternoon, everybody. I'm going to talk about something that is not only very close to my heart, but essential to every person living in South Africa, I believe. And it is the water we depend on. Now, I'm going to define a few concepts before I start, because these, I believe, are essential to our understanding of the problem as well. Firstly, let's define ecology. Ecology is the study of all abiotic and biotic factors that make up the ecosystem which sustains all life. Ecological resources are those abiotic, that's the air, water, minerals, space, and biotic, plants, animals, bacteria, and so forth, or a combination thereof, which occur in an ecosystem on which an organism depends to survive. Humans depend on the ecosystem for their own survival. And this is what we are going to focus upon today. Our water resources are being polluted by mainly industries, urbanization, farming, mining, and of course just general neglect. But mining in South Africa probably plays one of the major roles, especially in the northern parts of South Africa, in the pollution of our water. We see along the Witwatersrand a very serious example of this, where gold was discovered about 130 years ago, 124 years ago, and within a year, the whole of the Witwatersrand, or the best part of the Witwatersrand, was already being developed. And we see there the establishment of Johannesburg, Roodepoort, Krugersdorp, Germiston, Boksburg within 1 year. We saw in South Africa the urbanization of the Witwatersrand, which involved the settlement of the most people in the densest concentration over the shortest time in a region in the history of South Africa. And there was no urban planning, nothing. And all of this occurred right on the watershed of the Witwatersrand, which means that it impacts on two major river systems of South Africa, the Vaal River to the south, as well as the Limpopo River to the north, and the subsidiaries flowing into those. Originally, the mine works were small pick and shovel operations, but later on, as the people discovered that the gold ore dipped towards the south at a very steep angle, almost 45 degrees, they started deep mining. And deep mining implies that gold-bearing reefs are mined out, leaving concrete, wood, and natural rock pillars to support the roof or hanging wall. The sections that are mined out following the reef are called stopes. The stopes are connected via incline and vertical shafts. The mining technique has been perfected in South Africa gold fields and is still proven the best way to extract gold. But the logistical problems increased as the depth of the gold reef increased. There were problems with supplying the miners with air, cooling down the operational tunnels, and especially with the pumping of water that continuously flooded the mines. The names of many of the farms along the Witwatersrand were derived from the word fontein, or spring, such as Braamfontein, Durandfontein, Elandsfontein, Terfontein, Sterkfontein, Vogelstruisfontein, and of course springs. This is due to the proximity of the Witwatersrand supergroup to the dolomite-rich Transvaal supergroup with its karst aquifer. Those are the dolomites we were talking about just previously. Groundwater issued up to a century ago all along the length of the Witwatersrand, and from where the name Witwatersrand or Whitewater Ridge was derived. After the start of deep mining, the dewatering of the mines commenced and the springs dried up. And as the previous speaker referred to, that was the start of major problems. For instance, the sinkhole formation. Harmony Gold Mine, for instance, at a time, pumped 32 megaliters, that's 32 million liters of water per day from their operations into the Tweelopiespruit and Wonderfonteinspruit. Now there's another thing that nobody knew about or could predict before 120 years ago, and that is the formation of acid mine drainage. Gold often occurs in association with pyrite, which is iron sulfide. And we find that this molecule reacts with water and oxygen to form sulfuric acid. Sulfuric acid, of course, is highly acidic, and it erodes the substrate around it, and it releases the heavy metals, and of course other things that go with that. So what we see is that or dolomites are very soluble. Just normal rainwater with a little bit of carbon dioxide is enough to dissolve these subterranean cavities and tow lines and sinkholes and so forth. But with the addition of acid mine drainage, this whole process may be accelerated. And therefore also the whole of the surface will become more porous, allowing more water and other effluent to go into the water table. So over the past century, rock formations adjacent to the gold mines have been dewatered up to depths of over 3 kilometers underground. We have some of the deepest mines in the world. Some of them are now in the far west rand over 4 kilometers deep. And that means that the water has to be pumped down to that level and removed from the water table to prevent the mines from flooding. So most of the mines along the Central Rand and the West Rand reached their operational limits and were closed down over the past few decades. The pumping of many megaliters of water per day from the mines on the West Rand was stopped in 1998.